Well, that's it, guys. I guess back to normal life.
Guys, the presentation.
Hello again. We are Team 2, aka the Grail Gobblers.
Time to wrap things up for this 21-10 competition season.
We will once again review our problem understanding, then introduce to you the final design, the Grail Gobbler.
We will revisit our playing tools and design alternatives, then reveal our competition results.
And be done!
This video covers the Grail Gobblers' processes of planning, designing, and constructing a machine for the Fall 2016 ME2110 Final Design Project. The team has been on a quest to build a machine that scores points by defeating the Black Knight, gathering shrubbery, delivering the Holy Hand Grenades, and retrieving the Holy Grail. The tasks are performed in under 40 seconds on a 7x7 competition arena while competing against 3 other teams.
The final assembled integrated system is based on an angled frame with 2 sets of drawer slides. Upon startup, actuators push the movable platform and the drawer slides allow gravitational force to carry the platform up to the beast layer and push the shrubbery arms into the arena. From this point, the grenades and shrubbery systems are able to perform their respective tasks. Then at the end of the run, the platform is pulled back out of the blast zone by a string attached to the big motor on the back pillar. The motor continues the pull of the platform until the lift platform has successfully retrieved the Black Knight.
Here we see the Black Knight defeating subsystem. The sliding platform contains an extension on the bottom, aligned perpendicular to the floor. A hook on a hinge is positioned on the back of it with freedom to bend when gliding over the Knight upon initial extension of the platform, but then clutches the Knight during the system's retreat. Since each team has their own Black Knight to defeat without competing with other teams, this is not a time-sensitive task. Therefore, the Grail Gobbler addresses the Black Knight towards the end of the 40-second run.
The shrubbery collecting system rests back on the sides of the sliding platform. Supports keep the arms in place and closed for boxing. Upon startup, the platform slides forward, pushing the arms into the center of the arena. As they move forward, mousetraps propel the arms open at a set outward angle. Once the arms hit the floor, a motor and string pull the arms to corral shrubbery into the corners of the home zone. This subsystem needs to activate quickly because the shrubbery are being pursued by neighboring machines.
Here's the grenade delivering subsystem. The 3D printed turnstile spins freely and features 5 prongs, partially reaching into the beast layer while blocking the grenade passageway. The grenades sit in a tunnel slanted by the platform's orientation, so they have a tendency to roll downward toward the layer. The turnstile is engineered to turn roughly 72 degrees at a time, as individual prongs are caught and pushed by the walls in the beast layer.
Here's the bill of materials for the final machine. It shows that 7 different items made up the expenses for the project. The majority of the cost for the project, 53% of the total, came from the 2 sets of drawer slides, an essential feature of the design. The second highest cost for the project comes from the wood for the frame and platform. The 2 lumber items totaled to $17.73 and account for 30% of the total machine cost. An approximation of $2.50 was made for the cost of the few pieces of scrap wood used in the construction of the machine. Other expenses came from hinges and corner braces used to operate and store the subsystems. These items have a value of $8.21 and account for the remaining 14% of the machine cost.
The House of Quality defines the customer needs of this assignment, which derive from machine specifications concerning completion of the competition tasks. Critical customer requirements include successful egress from blast zone, loading grenades into 4 quadrants, fit within size constraint, and autonomous operation, which all rank 10 in importance. No blank rows exist, meaning the engineering requirements address all customer needs. Based on the relative values and overall importance calculations of these engineering requirements, the greatest efforts were directed towards satisfying range of motion, efficient code and robot execution, and stability.
The morphological chart depicts ideas for accomplishing the bottom line tasks established by the function tree. Some initial ideas in the first column represent the obvious, typical solutions most teams will consider. Moving toward the 4th column, the ideas tend to get more creative, but also more complex. The team continued down this path, brainstorming more atypical ideas to test. This led to a working solution and helped the team anticipate certain tactics many other teams used in order to combat common threats.
Our first alternative is nicknamed the Hammer because of its characteristic Black Knight defeating subsystem. This hammer is a sweeping arm with a heavy head held up at an angle to swing down into the arena. This subsystem should work like a golf club, powered by the mousetraps and gravity. The maximized torque should create enough momentum to launch the Black Knight far. The subsystem for gathering shrubbery features 2 swing arms, launched into the arena by mousetraps. Their hinges move in 2 dimensions, so they are powered by a motor and a string to rotate and collect shrubbery. The Holy Grail retrieving system works like a fly swatter to come down over the Grail, grip with flexible strands, and retreat.
The next alternative is called the hook and flip. The hook and flip gathers shrubbery with sweeping arms that fall out to the side upon startup and swing inward by the pull of a string connected to a motor. The system delivers grenades through a tube on a spring that oscillates up and down, allowing them to fall into the beast layer individually. This subsystem is connected to a main arm that flips over, slinging a hoop around the Grail once the drawer slides fully extend, and pulls it backward when the system retreats at the end.
The next alternative is nicknamed the Scissor Grab. For defeating the Black Knight, this alternative scoops the bone forward upon activation before hitting it with a hammer into the adjacent zone. While conceptually this idea was preferred, it ended up being difficult to implement, requiring a significant amount of energy to power. The Grail retrieving mechanism is modeled like a scissor lift to reach to the top of the beast layer and then easily retract after securing hold of the Grail. The rover is unique because it physically moves completely into the arena to compete. The design is compact for easy movement. It pushes the Black Knight into an adjacent zone with the front shovel. It collects shrubbery with anchor-shaped arms that are pushed outward upon start with actuators, but can only tackle one side at a time. The rover delivers grenades through a tube that presses up against the beast layer and controls the dispensing of grenades with the opening of a latch that catches on the inner walls. The rover retrieves the Grail with a grip that surrounds the stem, pulls together by a motor and string, and pulls back when the rover retreats.
The evaluation matrix quantifies the strengths and weaknesses of the alternative designs. The Grail Gobbler scores the highest amongst the alternatives due to its high performance potential in more heavily weighted criteria. One important requirement for this machine is its ability to deliver grenades into the beast's lair. The Grail Gobbler scores the highest in this category because it uses a mechanical trigger that is consistently reliable and accurate. Gathering shrubbery is also an important requirement. The Grail Gobbler's shrubbery triggering mechanism is an efficient use of gravitational energy, and its arms are taller than many competitors, allowing it to block other arms and consistently collect 6 of the available 8 shrubbery. A distinct characteristic of the Grail Gobbler is that it doesn't actually grab the Grail. The team found the top of the beast's lair to be a highly contested over space, so a Grail-grabbing subsystem must combat contact with other machines. The evaluation matrix demonstrates how the lack of a Grail subsystem improves the Grail Gobbler's score in related categories by reducing the risk of failure for other subsystems. Furthermore, the team was able to dedicate more time and effort toward refining the other subsystems to improve their scores.
For the final design competition, the Grail Gobblers performed at a satisfactory level, competing in 3 rounds and achieving 1 win. The team made a setup error in round 1, causing the machine not to deploy. The second round was very successful, so all subsystems worked well, as expected. In the third round, the team faced a competitor that swept the Grail Gobbler's grenades out of the beast layer, which was a threat the team did not foresee nor design to combat. The grenade subsystem is consistently the Grail Gobbler's biggest source of points. The team also struggled with the shrubbery arms motor staying fixed to the spool.
Overall, the team is proud of their performance and product of extremely hard work over the past few weeks. Some ways the group wishes that they had built the machine differently include installing the shrubbery arms to be pushed directly by the actuators and improving the ease of the setup process. The Grail Gobbler would collect more shrubbery if the arms could reach the ground before other teams, so this direct initial push would drastically improve the team's score. Furthermore, the shrubbery arms were too difficult to set up because the tension in the strings had to be very particular. There was no method established for ensuring replicability of this characteristic, so the team resorted to estimation, which was far too risky.
The Grail Gobblers believe that they particularly excel at planning long-term goals, upholding responsibilities, delegating tasks, thinking creatively, and collaborating.
Some areas the team has improved in during this experience and would like to continue to improve in are meeting deadlines, measure twice, cut once, patiently testing often, and applying a more perfectionistic attitude.
Our fans have asked what our plans are for post-2110.
Tony, having discovered the magic of coffee, will be developing his new product involving the infusion of coffee beans with Red Bull.
Allie wants to keep finding pretty leaves.
Tommy will be switching to ME, even though he's a 5th year.
And Miranda is not actually a Georgia Tech student. It was all an act.